Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwasos Ukobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 6. It says the balanced equation below represents the reaction that reaches equilibrium in a sealed container. So we are given the equation here, and then we are also given, looking at this part here, that this is an exothermic reaction. Now they say to increase the yield of ammonia, adjustments are made to the temperature, pressure, and concentration of the equilibrium mixture. The graph below represents the results obtained. Now, okay, it says identify the changes made to the equilibrium mixture at each of the following times, right? So looking at T1, so let's fixate our eyes on T1 here. So looking at T1, we can see what happened here. There's a spike up only on the N2 concentration, but then the concentration of H2 here just immediately decreases like that, and then NH3 immediately increases like that. Now, obviously, this would have to tell you if there is only a spike up on one of these reactants here, and then the other reactant does not spike up or spike down, it simply just smoothly decreases like that, and then the NH3 is smoothly increasing like this. This is telling you that the effect that has been done there is an increase only on the concentration of the N2. Because we can see there's only at T1 there's only a spike up of the N2, which increases the concentration of the N2. So for T1, we would have to explain there was an increase. There is an increase in concentration of N2. So N2 there was increased, right? And then how do we further back that? We know that increasing the concentration of the reactant. Remember, if we increase concentration of reactants, then forward reaction is favored. And then if forward reaction is favored, then we know eventually the concentration of the product will increase, right? While concentration of reactants decreases. Let's see if that happens. Immediately we see a spike up from the concentration of N2. What happens immediately after that? There is a decrease or a decline in the concentration of both the reactants. Why? Because the reactants are being used up. But as much as the reactants are being used up, what is happening to the product? The products are being formed in the same breath, right? So we are decreasing the concentration of the reactants and then increasing the concentration of the product as a result of increasing one of the reactants, the concentration of one of the reactants. So we can see that T1 there was an increase in the concentration of N2. Now let's continue and look at the effect that was done at T2, right? Now looking at T2, we can see that from all the substances, there's a spike up. So there's a spike up in the number of NH3, there's a spike up in the number of H2, and then there's a spike up from the number of N2. Now the effect that suggests that the effect that would have been tampered with here, so that we see those results, would obviously have to be pressure, right? So we would say the pressure of the system has been tampered with. So now the question is, was the pressure increased or decreased? A spike up in terms of the pressure means that the pressure of the system was increased. So every time you want to note the effect of pressure, you will see it by a spike up or a spike down in all of the reactants or in all of the substances that are involved in the chemical reaction, whether they're reactants or products. So they will all have to spike up if pressure has been increased. And if pressure has been decreased, they would all have to spike down, right? And then, okay, so how do we explain that? I say here there was an increase in the pressure. So there was an increase in the pressure of the system. Now, we do know that obviously an increase in pressure would have to either favor the reverse or the forward reaction based on the facts that we know here. Here, the coefficient is 1 and 3, so it's 4. Sum of coefficient of the gas moles is 4, and then sum of coefficient of the gas moles is 2. Now, we do know that an increase in pressure does what? An increase in pressure favors the reaction that produces less number of gas moles. Less number of gas moles. Now, looking at this, we can tell that the forward reaction obviously will have to be the one that is favored because it is the one that produces less number of gas moles. There is 2 as compared to the reverse reaction that actually produces 4. So now let's note, was the forward reaction favored? If the forward reaction is favored, then we would have to notice an increase in the concentration of the product, and we have to notice a decrease in the concentration of the reactants. Now, looking at T2, we can see exactly just that. So the concentration of the reactants, both the reactants N2 and H2, decreasing, but what is happening to the concentration of the NH3? We can see it increasing there. So this suggests that the pressure of the system has been increased, and therefore the forward reaction is favored. If forward reaction is favored, then the concentration of the product increases while the concentration of the reactants decreases. Now let's look at T3. What has been done at T3? So at this point, we can see that we've spoken about an increase in concentration. We've spoken about an increase in the pressure. So if they said they made adjustment on all of temperature, pressure, and concentration, that means T3, it's only remaining for the temperature. But then the question is, what was done to the temperature? Was that temperature increased or decreased? Now let's look here. Our enthalpy change is less than 0, suggesting that the forward reaction is exothermic, right? But then looking at what is happening to T3 here, we can see that the concentration of both the reactants is increasing, but the concentration of the product is decreasing, right? Now, if the concentration of the reactant is increasing, this tells us that the reverse reaction has been favored. So the reverse reaction is favored, right? But then we know that according to this, if the forward reaction is exothermic, then the reverse reaction is exothermic. So we say the reverse reaction is endothermic. Endothermic. Right. Now, if we say the reverse reaction is favored and also the reverse reaction is endothermic, we know that an increase in temperature favors the endothermic reaction, right? So that means since the reverse reaction is favored and the reverse reaction is endothermic, that means there has been an increase in temperature, because the only effect that favors the endothermic reaction is an increase in temperature. So in T3, we can confidently say that there was an increase in temperature. So there was an increase in temperature. And then now we can see that as much as those were only 1-mark questions, there was a lot of thought that needed to go into having to land up with the correct answer there. So you need to understand how to interpret those graphs there. So make sure that you go back to all these explanations that I tried to give you here. So, but then to just give you the outlines, if you see a spike in one of the reactants, and then when you are looking at the product or the reactant, you can see there are no spikes, then that has to be the concentration. If you see a spike in all of the substances that are involved in the chemical reaction, then that has to be pressure. If you don't see no spikes, but then it's just smoothly increasing or smoothly decreasing, then it has to be temperature. Note that with temperature, there is no spike up, there is no spike down. So it's either smoothly increasing or smoothly decreasing. Okay, so we have a 6.2. It says state Le Chatelier principle in words. When the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. Okay, so 6.3, it says the pressure of the reaction mixture in question 6.1 is disturbed by increasing the volume. Note, they're increasing the volume. That means what are they doing? They're decreasing the pressure, because volume and pressure are inversely proportional. So an increase in volume means a decrease in pressure. So they're decreasing pressure. How will the change above affect the yield of NH3? Write down only increases, decreases, or remains the same. Now, we do understand that a decrease in pressure, according to Le Chatelier, a decrease in pressure favors the reaction that produces more number of gas moles. So considering that fact, if we have to go back here, this is 1 and this is 3. So the sum of gas coefficient here is 4. And then the sum of gas coefficient here, that's 2. So this obviously tells us that the reverse reaction is the one that will be favored. If the reverse reaction is the one that is favored, then we do understand that the products now will have to be used up. So remember, favoring the forward reaction, that means we're using up the product to form back the reactant. So what will happen to the yield of NH3? The answer is it decreases. So if you are favoring the forward reaction, the concentration of the reactants will increase while the concentration of the product decreases. Now 6.3.3, they're saying use Le Chatelier's principle to explain the answer to question 6.3.1. And there is our explanation there. We say a decrease in pressure favors the reaction that produces more number of gas moles, right? And then we say, in that case, the reverse reaction produces more number of gas moles. The reverse reaction produces more number of gas moles. Therefore, reverse reaction is favored. Therefore, reverse reaction is favored. And then if reverse reaction is favored, the yield of NH3 decreases. Then you can add while the yield of N2 and H2 will have to increase, right? So all they wanted to know is what will happen to the yield of NH3. So you put it like that: a decrease in pressure favors the reaction that produces more number of gas moles. The reverse reaction is the one that produces more number of gas moles. Therefore, the reverse reaction is the one that will be favored. If the reverse reaction is the one that is favored, then understand this: the concentration of the products will have to decrease while the concentration of the reactants increases. That's how you explain according to Le Chatelier's principle, right? So you note that. Okay, then let's get to 6.4. It says 5 mole of N2 and 5 mole of H2 are now sealed into a 5D M³ empty container. Equilibrium is reached at 450 degrees Celsius. Upon analysis of the Kc equilibrium mixture, it is found that the mass of NH3 is 20.4 grams. So we're at equilibrium. So calculate the nature of the equilibrium constant, Kc, at 450 degrees Celsius. Then first thing that we have to do is, let's have our table. Okay, so the ratio here we can see following this, that's 1, 3, 2. So I like to write these ones up here so that I don't forget. 3H2, and then here I have 2NH3. Right. So initially they said there's 5 moles of this, and then also 5 mole of that. Because we are starting from the beginning of the reaction, then our product will have to be 0, of course. And then they're saying, upon analysis of the equilibrium mixture, so they're observing this at equilibrium, it is found that the mass of NH3 is 20.4 grams. So here, but then remember, we need the number of moles, not the mass. So what we need to do now is, let's calculate number of moles of NH3 using that mass. So we have M over big M. So that's 20.4 divided by the molar mass of NH3, that's 14 plus 3, that's 17. Then if we divide that, we get 1.2 mole, right? So we have 1.2 here. And then that's 1.2. Okay, so now in order to get this one here, we do understand, because the forward reaction was favored in this reaction, then we know that that's I plus C is equals to E for the products. So this happens if forward reaction is being favored. And then for the reactants, it's I minus C is equals to E, right? So we have to subtract from the reactants and then add on the product side. So obviously, if we say 0 plus a certain number here, we must get 1.2. So we do understand that it was supposed to be plus that 1.2. But now that we have this one value from the change block, we know that we can now use that. We can now use the ratio to find the values for the other, to find the values of the other substances, right? So using the ratio here, we know that we need to say 1.2 multiplied by 3. So note how I do it. It's 1.2 multiplied by 3, then divided by 2. 1.2, multiply it with this one, and then the answer you divide by 2. Now, when you do that, you get a 1.8, right? So we'll say 1.8 here. But then note what we need to do with this 1.8. We need to subtract because we actually have this for the reactants. And then again, if I want to find for this one, come here again, 1.2 multiplied by 1, then divided by 2. Again, 1.2, you multiply it with this and then divide by that. And then the answer that you get is 0.6. But then remember, we are subtracting from the reactants. So to get our equilibrium number of moles, that's 5 minus 0.6, which will give us 4.4 moles. And then here, that's 5 minus 1.8, which will give us 3.2 moles. But then in order to find our concentration now, we have to go back and read here. They told us that this is sealed in a 5D M³ container. So to get our concentration, we understand it's the number of moles at equilibrium divided by the volume. So we have to divide all these numbers here by 5. So 4.4 divided by 5, that's 0.88. 3.2 divided by 5, that's 0.64. 1.2 divided by 5, that's 0.24. Right. Now to calculate our Kc, now it's very simple. Since now we have all those concentrations, so all you need to do at that point, say Kc Kc is equals to concentration of the product NH3, and then with that ratio used as the exponent, and then we have concentration of H2 with that ratio there used as an exponent multiplied by the concentration of N2. So the ratio is 1, so even if you can say to the exponent of 1, it's the same, right? Then what is our concentration? Note that as soon as you are now substituting the values, the square brackets no longer apply. Remember, square bracket means concentration. So when you read this, you say concentration of NH3, concentration of H2, concentration of N2. But as soon as you now substitute in the values, you have to use round brackets. So that's 0.24 and then square over concentration of H2, that's 0.64, and then cube that, and then multiply by 0.88. Right. Now, having to punch all that into your calculator, you now have your Kc is equals to 0.25. So we have 0.25. Note that there is no SI unit because Kc is mainly just a ratio, right? So there's no SI unit there. Okay, so that's how you would calculate your Kc for a whopping 9 marks. So if you understand that, then you have your free marks like that. Okay, and then now we have 6.5. It says the temperature is now increased to 700 degrees Celsius. So from 450 to 700 degrees Celsius. What will happen to the value of the Kc at this temperature once a new equilibrium was reached? Write down only remains the same, increase or decrease, right? Okay, so now let's understand this. This is an exothermic reaction. And then this is an exothermic reaction. Number one, we know an increase in temperature favors the endothermic reaction. Now, if the forward reaction is exothermic, that means reverse reaction is favored. Now, if the reverse reaction is favored, that means concentration of the reactants will be greater than the concentration of the products. Now, Kc is bigger if concentration of products becomes greater than concentration of reactants. But Kc is smaller if the product this time around, the concentration of the product will be less than the concentration of the reactant, meaning the reactants are now the ones that are greater than the product. So Kc will be small, right? Okay, or we can put it like this: Kc is greater than 1 if concentration of product is greater than concentration of reactants. Then Kc is less than 1 if concentration of product is less than concentration of reactants. So to answer this question here, if the reverse reaction is the one that is being favored, we find our concentration of the reactants will be greater than concentration of products. How will this affect our Kc? Our Kc would have to be smaller than, right? So it has to decrease. So to answer that, we need to say decrease because of those reasons there. Okay, so please press the thumbs up button if you've enjoyed the lesson, then you found it helpful. If you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.